Little practice on some special right triangles. You're getting pretty good at it. Know that these pictures are what you'll see and use often on like SAT prep. They're common questions to see if you can recognize patterns and relationships in special right triangles. Here's a tip. You'll get these memorized and you'll have them, but it's for ease. I look at this 45, 45, 90, and I think of it as a flow chart. If I want to go from one side, short side, both of them are identical, to the hypotenuse, I multiply by square root of 2. If I want to go back, if I have the hypotenuse and I want to go back to the short side, I divide by square root of 2, the opposite operation. That's what we're doing in this one. The hypotenuse here is 14. So that really represents like the x radical 2. And so to get back to x, I need to take 14 divided by square root of 2. Now in this case, we do not allow roots in the denominator, so we rationalize it, and that means you multiply by 1. But in this case, it's 1 disguised as root 2 over root 2, and that becomes 14 radical 2 over 2. The 2 goes into 14, 7 radical 2. And I believe that is 9.9, it's bigger than 7. 7 square root of 2, 9.899, 2 decimal places. 9.899 will become 9.90. In this 30, 60, 90, the patterns are a little bit tougher because there's 3 different sides. I always use the anchor here in my X, in my template, and to get from the side opposite 30, which is what I call the short side, to the hypotenuse, you multiply by 2. So there's the little key that I multiply by 2. To get from the hypotenuse back to the short side, I divide by square root of 2. To get from the short side to the long side, you multiply by square root of 3. And to get backwards from long side, side opposite 60, back to short side, you divide by root 3. You can always confirm these using the Pythagorean theorem, but I think having this kind of handy it saves you a lot of time. The best way to go from long side to hypotenuse is to divide by 3 and then double it. So in this problem number 6, we've got the hypotenuse is 15, and this looks like a 30, 60, 90 right triangle. So sometimes it's good to put the ratios out there. If this is your x, this is x radical 3, and this is 2x. So in this case, the hypotenuse is 15. It represents 2x in the hypotenuse on this 30, 60, 90. So I'm going to divide by 2 to get x. That is 15 over 2, or 7.5. And then, now we're here, right there. To get to the long side, the side opposite 60, we multiply by square root of 3. So I think answer for this one is going to be, we keep it in 7.5 square root of 3. Okay, those two were good warm-ups for this number 7. Oh, it's so rich. Find the missing values. I think there's several ways to work at it, but I know you kind of have to zoom in and zoom out. By that I mean you got to see this as several different triangles. And let's look at that first. Here is a 90, 60, that's going to be 30. Let's see, let me rewrite it here. And then look at this triangle here. This medium-sized one has 90, 30, so that means this angle here is 60, And if this is a 90-degree angle here, that's a linear pair. We got 30, 60, 90 right triangles, 3 different ones of them. So let's look at the big one first. And I'll actually maybe write it like this so that you can see. Here's 2 root 3. There's 60. There's 30. There's a right angle. Oh, we have matched. This is the square root of 3 in the template, x and 2x. So in order to get backwards, to get the short side, I divide by the square root of 3. Oh, that's nice. 2 radical 3 over radical 3 is just 2. That there is 2. It doesn't get us what we need yet, but it definitely solves the problem. Oh, I could find out this whole length. I'm just going to play around here, because 2 radical 3 squared plus 2 squared equals c squared. That means that's 6 plus, let's see, that's 12 plus 4 equals 16. C squared equals 16. C must be equal to 4. So I know that this whole x plus y is equal to 4. I don't know if that's helpful, but maybe this was helpful in kind of seeing my thinking here. All right, let's clear out some space and let's go after what 2 lengths that we haven't even gotten to yet. X and y. Let's see. Aha, look at this. This short triangle here is a 30, 60, 90. Let's amplify it out here. And it's good to see these right triangles, special right triangles, in inverted ways, ways that are not always the way you like to see them. I know the hypotenuse here is 2, and that matches with 2x. There's x root 3. Oh, I see the template of my 30, 60, 90, always. Oh, so look at this. If I wanted to go from the hypotenuse back to the short side, or the side opposite 30, I divide by 2. Is it that simple? Is x equal 1? Or sorry, is y equal to 1 in that case? And x then would be equal to 3. Let's just double check. Since you've been watching this long, might as well stick around and double check. I'm going to take this triangle here and double check to see that if this is 2 radical 3 and this is a 60, 30 right triangle, then this is going back this way. That's going to be radical 3 because I divided by 2. And then to get to the long side, I multiply by radical 3. Radical 3 times radical 3 equals radical 9, or 3. Get out. X equals 3, y equals